So here's a question for you. What actually happens when you put a bunch of AIs on a team? I mean, do you get this brilliant, super intelligent hive mind, or do you just get a bunch of digital noise? That's the puzzle we're really digging into today. How do AI teams actually get smart?
And it's a huge question, right? You take all these powerful large language models and stick them together. Do their smarts kind of multiply into something amazing? Or do they just, I don't know, trip over each other? Well, it turns out the answer really comes down to one powerful idea.
And that idea is called emergence. It's basically the secret sauce. It's what makes any great team great. Think about a flock of birds or a championship basketball team, or, as we're about to see, a team of AIs. It's that magic moment when the group becomes way, way smarter than any single member. But how on earth do you even test for that in an AI? Well, to figure that out, some researchers at Northeastern University came up with a really clever experiment. They created this group guessing game. Now, on the surface, it sounds super simple, but it's actually almost impossible to solve without some real, genuine teamwork. Okay, so here's the setup. You've got a team of 10 AI agents, and their job is to guess a secret number. Simple, right? Each one makes a private guess. They have no idea what the others are picking. Then all those guesses get added up. And here's the thing. The only feedback the whole group gets is whether their total was too high or too low. That's it. And they just keep guessing until they nail the target. Seems straightforward, but there's a huge catch.
And that catch is there's zero communication between them. Absolutely none. They can't send messages. They can't see each other's guesses. Nothing. They have to figure out how to work together based only on that one shared piece of feedback. I mean, how is that even possible? That's the million-dollar question the researchers wanted to answer.
So, to figure out what could possibly encourage this kind of silent teamwork, the researchers decided to test 3 different ways of managing the teams. And they did it using nothing but the very first instructions, the prompts they gave to each AI. Okay, so they set up 3 teams. First, you had the plain team. They just got the basic rules of the game, nothing fancy. Then you had the persona team. Here, each AI was given a unique personality, like you're an engineer or you're an artist. And then the third team, they got the same personas, plus one tiny, crucial instruction. Think about what the other agents might do. This little nudge is meant to activate what we call a theory of mind, basically, the ability to think about what others are thinking. It's a tiny little change in the prompt, but as you'll see, it had huge consequences. And get this, these personas weren't just for fun. The AIs really leaned into them. For instance, an AI given a cowboy persona actually explained its strategy by talking about its experience corralling cattle or wrangling numbers. It's kind of funny, but it's also amazing because it shows the AIs were genuinely using these roles to shape their thinking. So we've got our 3 teams, our 3 different management styles. The big question is, which one did the best? Well, the answer is probably not what you're thinking. And it gets right to the heart of what it takes to create real synergy in an AI team. Now, the first set of results was, well, kind of weird. Because when you just look at the success rate, it seemed like the prompts didn't matter at all. The plain team, the persona team, the theory of mind team, they all succeeded about 60% of the time. On the surface, it looked like a total tie, a wash. So you have to ask, right? If they all won at pretty much the same rate, were they really any different? Were they all just doing the same thing? And the answer is a huge, emphatic no. The real story wasn't that they succeeded, but how they got there. And this is the aha moment. The researchers started to measure how differently each agent was behaving from its teammates. They called this agent differentiation. And suddenly, the picture became crystal clear. The plain team, they all acted the same, like one big blob. But when you gave the AIs personas, they started to specialize. And that theory of mind prompt, it pushed them to the highest level of differentiation. They weren't a blob anymore. They were a team of individual specialists. And that useful diversity, that specialization, that's the definition of synergy. It's the new information that the group creates together that no single member had on their own. It's like the team literally develops a collective brain, one that's way smarter than any of the individual AI brains that make it up. So this brings us to what are really the 2 key ingredients for any amazing team. First, you need that synergy, those useful differences where everybody has their own special part to play. But you also need redundancy. That's just a fancy word for making sure everyone shares the same goal and is working together to get there. And here's the most important part.
You need both. You can't just have one. If you have too much redundancy, everybody just does the exact same thing, like our plane team. But if you have too much synergy without that shared goal, well, that's just chaos. Real success, that emergence we talked about, happens right in that sweet spot where you have both. You know, the perfect way to think about it is like a great jazz band. You've got all these amazing musicians, the drummer, the bassist, the pianist. Each one is a super talented individual playing their own unique part. That's your synergy. But they're all playing the same song. They're in the same key. They're keeping the same tempo. That's your redundancy. And it's that perfect blend of both that makes for unbelievable music. Okay, a jazz band of AIs is a cool idea, but why does any of this really matter? What are the real-world stakes here? Well, this is about a massive shift in how we think about AI. We're moving away from just seeing them as individual tools and toward a future where we can actually design them to be smart, collaborative teams.
It matters because this experiment literally gives us a blueprint for how to build smarter AI teams. It turns out that that one simple prompt, that theory of mind instruction to think about what others might do, that was the magic key. It was the perfect little push that created both the synergy, the differentiation, and the redundancy, the goal alignment. It's what turned a random collection of AIs into a genuinely intelligent team.
But, and this is a really important but, it's not automatic. This doesn't just work with any AI. When the researchers tried this whole thing with a smaller, less capable model, the team failed. They just couldn't figure out how to coordinate. And that's huge, because it proves that for this kind of teamwork to emerge, the individual AIs have to be powerful enough to do this kind of complex, group-focused thinking in the first place.
And really, that's the big takeaway here. We're not just watching AI happen. We can be the architects. We can be the designers. With something as simple and elegant as a well-written prompt, we can guide a bunch of AIs from being a disorganized crowd into being a truly collaborative, super smart team.
So that leaves us with one final, pretty mind-blowing question. If we can now start designing AI teams that are smarter than the sum of their parts, what's next? What are the limits? I mean, what kind of massive, complex problems in science or medicine or engineering could a team like that solve together? The possibilities, you could say, are just starting to emerge.